Look back at the edge of a black hole, and you'll see 100 versions of yourself. This isn't magic, it's the photon sphere. 15 seconds later, even light can't escape your eyes. Today, we're diving into a wild topic. What happens if we toss you into a black hole? This isn't sci-fi. It's legit speculation based on hardcore physics. Before we throw you in, let's quickly recap what a black hole even is. Even Einstein, that old genius, described a black hole as where God divides by zero. He didn't even believe these things could actually exist in our universe. But guess what? Humans actually found them. When massive, super-dense stars reach the end of their lives, they go through an epic transformation and collapse in on themselves. Nothing's left. What they create is called a singularity, a mysterious point in space-time said to have infinite density and therefore infinite gravity. General relativity gave us a game-changing idea. Gravity isn't a force acting on objects, it's just space-time curving because of an object's mass. It perfectly explains how Earth orbits the Sun and how planets spin like they're circling their home. Spinning. There's no solid black surface inside a black hole. The singularity inside is just so insanely dense, it warps space-time like crazy, forming a deep well with vertical walls. In 1939, Einstein himself published a paper saying stars collapsing into singularities was nonsense and wouldn't happen in our universe. But funny enough, that same year, that famous Oppenheimer and physicist Hartland Snyder co-published a paper predicting that stars could indeed collapse under their own gravity into black holes. So, back to tossing you into a black hole. What happens? The wildest thing about black holes is anything can become one. Whether you're a star, a planet, or a puny human like us, if you're squished into the right Schwarzschild radius range, you'll turn into a black hole. German physicist Karl Schwarzschild was the first to find an exact solution to Einstein's equations, a discovery that's both simple and beautiful. Take our sun, for example. If you compressed all its mass into a sphere just 3 kilometers in radius, boom, it's a black hole. The Earth? It'd become a sphere about 9 millimeters across, roughly the size of a marble. If a human wanted to become a black hole, it'd be brutal. You'd have to be squished smaller than a proton, unbelievably tiny. But if you got that small, yep, you'd be a black hole. So, which black hole should we toss you into? I think it's time to throw you into one, but which one do we pick? We could go with a small one, but that's kind of boring. Let's pick a big one instead. Some black holes have event horizons bigger than our entire solar system, weighing billions of solar masses. But that's a bit overkill. How about one closer to home? Sagittarius A, the supermassive black hole at the center of our Milky Way. You're already orbiting it. It's also one of only 2 black holes humans have ever photographed. Now, let's set the scene. Imagine you and I fly out there and park our spaceship 10 billion meters from the event horizon. We're sending you toward the black hole. As you freefall, I'll stay on the ship, watching. Here's the kicker. General relativity tells us that near a black hole, time can feel totally different for different people. Because black holes warp space-time so intensely, Interstellar showed this effect perfectly. To keep track of time, we'll give you a special watch that shows time from your perspective and mine on the spaceship. We sync the watches and your black hole adventure begins. As your journey starts, you see the black hole in the distance, devouring matter at a crazy pace. The scene is jaw-dropping. Matter gets heated to insane temperatures from friction. If you tried simulating this on a regular laptop, it'd take over a decade. In reality, that disk would glow bright blue or white, but in this simulation, it's orange, to make it easier for us to see. You check your watch, only 30 minutes have passed. You've only covered 0.1% of the distance to the event horizon. So far, I'm only 11 seconds ahead of you on the ship. Not too wild yet. Now we're getting closer to the black hole. The bending of space-time around it is creating all sorts of weird visual effects. Light from the side, or even behind the black hole, gets bent before it reaches your eyes. Let's check time again. You've been gone for 2 hours, covering 1.4% of the distance. Now I'm 44 seconds ahead of you on the ship. That time gap's starting to feel a bit spooky, but it's not totally nuts yet. The dark shadow in the middle of the black hole seems to grow faster than expected, thanks to gravitational lensing. It bends light that would have passed you by right onto your retinas. A long time passes, and you check your watch again. This time, it freaks you out. From your perspective, it's been about 12 hours since you left. But for me, on the ship, I've been watching you drift toward the black hole for nearly 15.5 hours. We're super close to the black hole now, and things are about to get really weird. Before you hit the singularity, you'll reach a strange, mind-blowing place. If you could freeze in time at this special spot and look around, the view would blow your mind. You've reached the Photon sphere, one of the weirdest places in the known universe. In the Photon sphere, gravity is perfectly balanced, letting photons orbit the black hole. It's not matter emitting or reflecting light. The photons themselves are trapped in orbit. If a beam of light moves tangent to the black hole, it can stay in orbit, but if its path shifts even slightly, the photon either falls into the black hole or shoots off into space. Under these crazy conditions, if you freeze at the photon sphere and look around, you'll see mirrors of yourself staring back, multiple copies of the back of your head gazing out into space. You're literally seeing yourself like you're standing right beside you. No fancy tech needed, it's all just space-time doing its thing. As you keep going, you're getting super close to the event horizon. You've passed the photon sphere, and the black hole takes up more and more of your view. It feels like darkness is swallowing you. That's because the darkness warps around you, showing the back and sides of the black hole's shadow, plus parts that'd normally be visible in flat space-time. You've been gone for 13 hours now. In 24 minutes, you'll cross the event horizon. But from the ship, I've been watching your journey for nearly 20 hours. Another 18 minutes pass, and you check your watch again. Now I've been watching you for almost 40 hours. For you, those last 18 minutes felt like 18 minutes. But for me, they lasted a whole 18 hours. The final moments here. In 6 more minutes, you'll cross the black hole's event horizon. You close your eyes, take a deep breath, and check your watch. It looks broken. It says I've been watching you fall for an infinite amount of time. But it's not broken. That's just how physics works. I spent decades on the ship, watching you inch closer to the event horizon. Eventually, I see you turn red, meaning I'd need an infrared telescope to spot you. I'll never see you cross the event horizon, even if I live forever. For you, those last 6 minutes feel like 6 minutes, but for me on the ship, they last an eternity. Sounds like sci-fi, like a wild daydream, but it's 100% real. It comes straight from Einstein's equations. Now you're inside the event horizon, so what happens inside a black hole? Weirdly enough, you might not even notice when you cross the event horizon. You can still look out and see the universe, distant stars, even our spaceship floating in space. But all that light, just like you, is headed toward the singularity. You've passed the point of no return, that infinitely dense point where all our physical laws break down. Time itself stops. To escape the singularity's pull, you'd need to move faster than light, which we all know is impossible. There's a common myth that if you look out at the universe, extreme time dilation would let you see the entire future of the universe unfold. History, flashing before your eyes. But that's not true. Because of aberration, as you approach the singularity, the outside universe gets squeezed into a tiny ring. Finally, when you're close enough to the singularity, your feet get stretched out ahead. Your body gets spaghettified, stretched out in a process straight out of Italy. You merge with the black hole, drifting through the universe together until eternity. This whole process gives you chills just thinking about it, but you can't help wanting to explore it. Black holes, these mysterious cosmic beasts, are both terrifying and irresistible.